Good morning, grade 11 class. This is Wednesday, October 12th. Today we are going to be seeing a video lesson. Hi, how are you? I'm just recording these, pre-recording these lessons for you as I am away at Offset Golf. All right, so for day 3, which was yesterday, please save these questions for Friday. Today we're going to be looking at day 4, so you should have day 4 in front of you. Press pause at any time throughout the lesson, or even now, to make sure that everyone has day 4 in front of them. Go ahead, press pause. Okay, and then make sure you have day 4 in front of you. You should by now. I will be away today and on Thursday, so make sure you have your handouts. Make sure this is plugged in using the USB for volume. Our test is on Wednesday, October 19th, and peer teacher interviews are that day as well. All right, let's get started. So some terminology that we're going to be looking at in terms of exponential functions is that of continuous. Continuous just means that there are no breaks in the graph, so you have something that's just like continuous, right? And we're looking at exponential functions. Something that's increasing goes from the bottom up, so it increases as the y values increase, or x values increase. And decreasing is when the y values are decreasing, so going down the y, but the x is increasing. Okay, so kind of something like that, where we have this kind of like half arrow here, just because we're going to have something right here we're going to talk about in a second. Concavity refers to the nature of the function, so it's a minimum, then it's going to be like concave up. These are both concave up, so concave upwards. Meanwhile, we can have a reflection, which is a maximum, so concave downward. So we have like that kind of like flow looking down. These are flows going up. What I'm talking about here for that arrow, that half arrow that's kind of happening, is it's going to approach a line that's called an asymptote. So our exponential function kind of has this curve to it, but then it keeps on going on and on and on, and it never crosses this, what we call an asymptote. All right, so let's go look at a couple of these functions. All right, so our first function, we have y is equal to 2 to the power of x. Let's fill in this table here. So where we see an x, we're going to put -3. So here we have 2 to the -3. Well, we know this is 1 over 2 to the 3, which is 1 over 8. And 2 to the -2, well, this is 1 over 2 squared, which is 1 over 4. 2 to the -1 is 1 over 2 to the 1, which is a half. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. And 2 to the 3 is 8. All right, so we have our coordinates here, -3 and 1/8. Let's go plot that. So we go, this is our x, this is our y. So we go over 3 and up just an 1/8. Over to -2, up a quarter, up a half, up 1, over 1, up 2, over 2, up 4, and over 3, up to 4, 6, 7, oh, just right off the graph a little bit, 8. So we're going to have this gentle curve happening here. All right, is that increasing or decreasing? Press pause, go look back at the definition. Yeah, it's increasing. And we got to give it its name. It's y equals 2x. All right. Next, go ahead and try this one. I'll start you off though. So here again, we have 1 over 2 to the -3. And anytime we have a negative in the exponent, it flips the fraction and becomes a positive to get to the power 3, which is 8. And then here we have 1/2 as our function to the power of -2, which is 2 over 1 to the power of 2, which is 2 to the power of 2, because it's 2 to the power of 2, 1 to the power of 2, which is 2 to the power of 2 over 1 to the power of 2, and 1 to the power of 2 is just 1. So it's 4. 1 over 2 to the power of -1 is just 2 over 1 to the positive 1, which is just 2. Maybe you're seeing something over here, right? 8, 4, 2, 8, 4, 2. Yeah, hopefully you're seeing that. This is power 0, this is 1. 1/2 to the power of 1. So hopefully you can go ahead and finish this. Press pause. right? So we get 1 over 8. I'm going to graph this next one using a different color. All right, so again, we're over, start -3. At -3, we're up 8. 1, 2, 3. Over 2, we're at 4. 1, 2, 3, 4. So it looks like it's almost like the reverse. Okay, let's go ahead and this nice curve. Right, and I kind of did a half arrow there because this will always be getting closer and closer and closer, but will never touch. Right, so we have that fancy word called an asymptote. So this line right here would be, what's that? Y equals 0. This is y equals 0, and this is what we call the asymptote. So it's a line that it never touches. And if you don't believe me, go ahead on Desmos, go zoom in and see. You can kind of go like that on Desmos and see if the line will ever touch. We're going to be graphing those next. So go on Desmos, use your phone, go on Desmos, and you need to graph all of these functions in the same window. All right, so it should look a little bit like this. We've got y equals 2x, y equals 3 to the x, y equals 4 to the x, 10 to the x, and we'll talk about that one in a second. Right, so we can see that, if I'm going to just take these away, y is equal to 2 to the x. What are some similarities between these, and what's kind of like happening here? Yeah, they all share this y-intercept of 0, 1. We can see that the greater the number is, the more it is increasing, or the faster it's increasing. Great. We can also see that these lines will never touch. So if you just keep on zooming in, it's never going to touch the axis where y is equal to 0. So you can, I'm zooming in. See how the green one is like close, super close to 0, but believe me, there we go. It's not touching, right? And it's only because it's getting faster. It's going down, up faster, and down closer to the 0 faster than any other line. Right? So we can see that it's not touching. Right? And then here it says explain why y is equal to 1 to the x is not an exponential function. Let's go look at that. If you're stuck in a weird place, you can just hit the little house and it will default zoom out. All right, so why, oh my gosh, what do we get there? It's a line, right? It's a horizontal line. Why does that happen? Why does that happen? Well, like if we looked at a table of values and you subbed in values for x, you're gonna get 1 every single time, right? So it is a line. When y is equal to 1 to the x, therefore we get just y is equal to 1. It's a line where y is equal to 1, because any value you put in here, 1 to the power of -1, 1 to the power of 2, it's always going to just be 1. Right, examine the function here. So we just looked at them. What's the y-intercept? At 0, 1. Determine the x-intercept. Okay, so it's saying here to enter from -10 to -20 for x. Okay, we can do this by going over to the wrench, and then you can change your x values if you like to -20. So it's just looking at the window from -20 to -10. And let's go check out and see. So we're at -10, -20 with those x values, if it's ever crossing. So we're just going to zoom in and see. And it doesn't have to be from that space either. It's a little bit easier actually to see from over here. So we can see as the x values, right? These are the x values. They're getting smaller and smaller and smaller. Our y values are also getting smaller, but are they ever meeting? No, it's never meeting. Never. All right. So what do you notice about the y values? As the y values get smaller, they never reach 0. Okay, they get smaller, but they never reach 0. So it never crosses the x. So it never crosses the x-axis. All right, let's go ahead and check out the next one. So this just means that there's never going to be an x-intercept. So there are no x-intercepts. Or just intercept. There's no x-intercept. All right, so the next graph here, when we're looking at from 0, between 0 and 1, this just means that it's a fraction. All right, go ahead and graph those 4 functions out on Desmos. So here we are, we have the first one, and let's do 1 over 3, 1 over 4, and 1 over 10. Again, we can see the higher the denominator this time, the more steep it is getting, and the faster it is going towards the positive x-axis. This time, however, it again will never touch. Right? You can zoom in as far as you like, it'll never touch. Let's talk about some of these similarities here. So just looking at 1 over 2 to the power of x, we can see that we have a y-intercept of 0, 1. And again, determining the x-intercept, if you went and scrolled in or looked at the values of x between 10 and 20, we're going to notice the same thing as the y values decrease, or the y value is getting closer to 0. So they're decreasing, they're getting closer and closer and closer to 0, but do they ever become 0? No. So never equals 0, that means that there is going to be no x-intercept. So you can have a number, you can have the number like 1, and then 1 becomes like, like 0.9, and then 0.99, and then 0.999, and then like it's getting, or even the number 0, and then just a little bit more than 0 is like 0.00, like a million zeros, and then a 1. It's not 0 yet, it's getting closer to 0, but it will never touch. All right, so the general equation is y is equal to b the x. The asymptote is a horizontal line. The equation is y equals, well, we've been looking at the ones y equals 0. The x-intercept is there is none. The y-intercept has always been 0, 1. That is because the b for the function at 0 is 1. Anything to the power of 0 is 1. The continuity is continuous. There's no breaks in the curve. The concavity, so when we're looking at this one, we looked at like 2 to the power of x. This is the one where we started here and we went up a quarter and then up a half and then up 1 and then over 1 up 2 and then over 2 up 4. So what do you think the concavity here is? Concavity is definitely concave up. And is it increasing or decreasing? You're going from the bottom to the top. That means you're increasing. And this is to the x. This one, we were looking at the half to the power of x. So this would be the one where you're starting off really high. So this is 1, 2, 3, 4, and then over 2, 1, and then going this way. And then kind of put like half an arrow right here, half an arrow. This is y is equal to 1/2 x. Concavity again is, it's concave up. It's only concave down if it's a flip or reflection. And here we can see we're going from the top down. It's like a slide. It's decreasing. All right. So that's going to be it for this video. I'm going to have part 2 coming right at you next.